Hello everyone, welcome to ML with AP. The topic for today is pandas. We are going to apply 80-20 rule today. We are going to learn 20 commands which will get 80% of our work done. Let's start. But before we jump onto our Jupyter notebook and start seeing those 20 commands, let's see that why do we need pandas? Now we all know that pandas are great package, great library for doing EDA, exploratory data analysis in Python, but let's dive a little deeper. So pandas is essentially used for five purposes. One is if you have got a tabular data, and by tabular I mean something like a SQL table or an Excel sheet. Most of our real world data is anyway tabular. Pandas work great for that, and it is in fact built for a tabular data. Data ingestion, if you have to read the data from any data source, be it CSV, Excel, SQL database, anything, pandas is great over there. Data cleansing, one of the important milestone of our data pipeline. Null value treatment, filtering, anything to do with cleansing, pandas is great over there. Data exploration and transformation. Suppose you want to do univariate, multivariate analysis, you want to transform your data to fit your models. Pivot, group by, descriptive statistics, everything, all those tools are built in pandas. And last but not the least, the integration with other great libraries like Numpy, Matplotlib, and scikit-learn. Now, pandas is built on top of Numpy, and there were some shortcomings in Numpy. That's why pandas was built. Let's see that as well before we jump onto Jupyter Notebook. But the one question which comes to mind is why pandas? And why, when NumPy is already there, we already know NumPy, it's great, it's faster, why there was a need for pandas? So there are essentially three reasons. What NumPy is great with, NumPy was not built for tabular data, okay? So people who were coming from the SQL background were finding it challenging. Pandas to certain extent bridge that gap, right? So if you are if you have some experience in the databases, especially RDMS, this will look very familiar to you. The second is, and which is very important, is that pandas was built for numerical data. It's super fast as long as the data is numerical. But the real world data is heterogeneous. So you will have the tabular data in Excel sheet. You can have text, string, all sort of data, date type. You do not only play with the numerical data, right? So heterogeneous data types was not handled well in NumPy. Okay. Now, third important reason is the null value treatment. Pandas package or inbuilt methods or functions does not do well with the null values. Handling it became tedious. Now pandas came to the rescue. It has inbuilt mechanisms to quickly handle those null values. Okay, so these are the three reasons why pandas was built on top of NumPy. Now when pandas is dealing with heterogeneous data, it actually slows it down. If you ask me, NumPy is way faster than pandas, but the functionality which pandas give you over and above what NumPy gives you makes it a very, very important tool. So especially in the data science or machine learning field, both pandas and NumPy go hand in hand. Now let's jump onto our Jupyter notebook and see those 20 commands. Here is my Jupyter notebook, and we are going to see 20 commands which will get roughly 80% of our work done. Now, as I was saying, that pandas is great for exploratory data analysis, right? So most of these commands which I'm going to tell you are related to that, right? Let's jump in. But the first thing first, we have to import our libraries, right? So I'm importing pandas and NumPy. One of the things, the first thing we should do is we should always check the pandas version, right? And the way to check pandas version is pd dot underscore underscore two underscores version underscore underscore, right? Why we should check the pandas version? It is essentially for compatibility and portability reasons. Suppose you're moving your code, you're porting your code from one environment to another environment, one machine to another machine, right? It's very important that where you're going to run the code, it's also built at the same version where you have coded it initially, right? So compatibility and portability. Now the first thing, now pandas basic object type or data type is data frame. Okay, now pandas has data frame and series also. Series is nothing but a one column, a single column data series, right? That's what series is. A combination of series forms a data frame, right? Now you can create when I say data frame, think it like a Excel sheet, SQL table. So there will be a bunch of columns and bunch of rows. That's what data frame is. You can create data frames by various methods. You can ingest the data by reading a CSV file or any sort of file, JSON, or you can read it from the database. The other alternative is that you can pass a dict and you can create a data frame. You can pass a list also and you can create a data frame. Or you can pass a two-dimensional Numpy array also, right? So let's see first that how to create by reading a CSV file. Now this is the location of my GitHub repository, and I have uploaded the Titanic very famous dataset titanic.csv. Okay, so I'm passing this URL and I'm passing it to the method read_csv. So pd.read_csv. Read_csv is the method which will read it, and where it is going to store, it is going to store in Titanic, and Titanic is my data frame. So let's learn it. Let's run it. Now you can always run it in different ways also. So I defined a URL over here and a separator. So not always you will get your data files in a nicely comma separated file. The separator could be something else also. So you can pass a parameter separate is equal to separator. In this particular case, my file is stored in a comma separated fashion. So I'm reading it over there. This is just another way of doing it. Okay, let me learn that. So let me check the type of my Titanic object. So it says that panda_frame.data frame. So it's a data frame type of object. When I say data frame, I always remember that it's an Excel sheet type of data, right? Let's run the head command. The head command gives you the first 5 rows. So titanic.head is the way to run it. It will show you. So now my friend is the data frame, right? So there are rows, and the rows we'll come to how the labels work of the rows and the indexes. But if you see over here, there are columns and there are rows, and it's a tabular format of data. We can see that there are a bunch of rows, passenger ID, bunch of columns, passenger ID, survived, P class, name, sex, age, and various things. We can also see that rows are there and they are zero-based indexing. So they are numerical indexed, the 0th row and first row and second row and so forward. The head gives you the top 5 rows. Now the another way of creating that is through a dict. Now how can we create? Dict is a Python basic data type dictionary. And if you see over here, this is my dict, which I have highlighted over here. So I'm passing a dict with key value pair. How a dict works is name, and I'm passing Suresh and Rohini, gender, male and female, age 25 and 23. And I'm passing it through a data frame constructor. Let's see, and this is my data frame df. When I'm printing df, it gives you my name, gender, age will be the column, and my 0, 1, since I didn't put any label for my rows yet, it gives you a nice data frame. Now you can also, like how we were doing with a URL, you can also define a dict, my dict, in a dictionary over here, and then I'm passing that dict into the data frame constructor. It gives you the same thing. Okay, let's run it. Sometimes you need to create a data frame with random variables, and it's so tedious and difficult to type so many things. If you are playing around with pandas and you are doing some learning, then you need a base data frame, right, to play around with. And a good way to do that is you create a Numpy array with a random variable, and when I pass in np.random.rand, I pass the parameters 4, 8. That means it is 4 rows, 4 by 8. It will create a 4 by 8 two-dimensional matrix, right, or two-dimensional ND array. Now 4 rows and 8 columns. And what it is going to populate it with? It is going to populate with the random variable picked randomly from a standard normal Gaussian distribution. When I say standard normal Gaussian distribution, I mean that where the mean is centered around, the data is spread between 0 to 1, right? So all the values which you'll see over here will be 0 to 1, and I'm going to do it going to store it in a data frame. So my data frame looks like that, and if you notice, there is no label for the columns as well. So if you do not provide the label, by default pandas will give you 0 based indexing both for column and for rows. You can actually pass a parameter called columns, and you can specify what the column names should be. So you are specifying a column and you provide a list over there, and Pandas will go ahead and create the data frame with those labels. So the column labels are there. Okay, let's run it. Subsequently, you can also pass the index. The rows are called index in Pandas. You can also pass the index labels. So index labels are also passed in form of a list. My list is row 1, row 2, row 3, row 4, and I can pass it. And it will label my indexes or rows over here. You can pass both column and index or both column and rows, and both will be labeled, okay, like this. Now, sometime when we import any CSV file or read from the table, we do not like the name of those columns. They are not very intuitive. So sometimes we do want to change that. How to change those column names? Simple. We have to pass again a dictionary object. So the name, the earlier name, and the new name we can pass, and we'll say that hey, I want to change my column. So the axis should be column. Axis column is this axis. So there are two axes, axis 0 and axis 1. Axis 1 refers to your column axis. So I'm stating to Panda rename method that take this name, swap it with first name, and when I run this, it swapped my earlier name to first name. Okay, simple. Now, one of the core features of Pandas is to do your EDA. So we have to do a lot of analysis, right? Let's see that how we can do. Head we have already seen. It gives you the top 5 data points, and you can get some idea of what the data is. The tail subsequently gives you the last 5. One of the important commands is dataframe.info. This method is super powerful. So what it gives you a very rough, quick snapshot of what the data looks like, right? So let's see what data looks like. So I have 0 to 11, that means 12 columns. These are the column names. These are the non-null values present. So if you notice, there are how many total entries are there? 891. The total entries is 0 to 890, which is 891, and total 12 columns. Now, if you see, everything is 891, but age and your cabin has 204 non-null values. That means it has a lot of null values or not a number values, right? It also tells you what are the data types for these particular columns. So some of the data types, Pandas automatically tries to understand that they are storing integer, and it will get stored in a data type in 64. Sometimes it doesn't understand that it's a particular data type, and it will all those data types where it's not able to zero down on which exact D type is that, it will put into object. So if you see over here, the name, sex, ticket, cabin is also object type, right? We'll see how to deal with that a little later. The another thing is titany.describe. So df.describe, the describe method gives you a very good insight of your numerical data. So it will only output for the numerical data. These were the data which were integers, defined integers. So what it will give you? It will give you a descriptive statistics overview of this data frame. So you'll give that count, the number of counts which it had. Notice that the age has only 714 because it has null values. It will give you a mean, a standard deviation, minimum, first quartile, median, third quartile, and maximum value. So it will give you a rough idea of where the data lies, right, for each of these columns. Now, in case you need to get the unique count column-wise, that how many different type of data is stored over there, right? Or unique values are stored in each of the column, then you can run df.nunique. When you run nunique, it essentially tells you that, let's say my P class has only 3 unique values. Out of 891, there are only 3 unique values. So we can make sense out of it from here that looks like these are categorical variables, right? So there are like survived over here. If you see, they are only 0 and 1. So 0 is referring to not survived or died in the Titanic accident. 1 refers to somebody who has survived. So these are categorical attributes. Okay. So this gives you a quick snapshot of that what's out. If you see age, it doesn't matter. It's a continuous variable, right? It's a number. So there are 88 different sort of ages which are present in this data set. Okay. Now embarked, which is something which has only 3, perhaps this is also a categorical variable. We'll see a little later. Okay, now one of the things which we do when we do EDA is to slice and dice the data. And by slicing, there are two important methods which are available, lock and iLock. Now, pandas deal with the tabular data, right? And the reason why lock and iLock came into pandas was they wanted to replicate the list and ND array or the Numpy array type slicing features, right? So lock means that if you define it, if you call it by lock, that means you are selecting by labels, and iLock you are selecting by positions. Let me just explain it with an example what it means. Again, df.head or titanic.head. Now when I say df.lock or titanic.lock over here, and I am passing, if you see over here, I am passing lock, that means I'm calling it by label. By label, I mean the column label or the row labels. Now row over here are not labeled, they are by default zero-based numerical indexing, but the columns are labeled one. So if you notice, before the comma, this thing is referring to the row. When I say colon, and if you know about the list or the Numpy arrays, that means I'm calling all the rows. After comma, this is the column thing. So what I want it to print or output is start from the name column, go all the way till parch. So start from the name column over here and output everything till parch. So this particular slice I want, and not just for 5 rows, but for entire number of rows. And that is being depicted by this colon, right? Okay, so when I run this, it will give you this particular thing, right? So all 891 rows, and the columns which you see, name, sex, age, SIB, parch, only these, right? So this is the one way of slicing with lock feature. Now you can slice both with the lock, with the labeled indexing, you can slice both the rows and the columns. Suppose we are interested only in the from 2 to 30th rows, and again the name to parch. I can easily run it. So the rows slice from 2 to 30, column slice from name to parch, right? And it will output you from 2 to 30. What is iLock? iLock is the index based. So although it has a name over there, if you see my df.head, these columns have a name, but they also have a zero-based indexing implicitly, which is like passenger ID is 0, survived is 1, P class is 2, name is 3, and so on and so forth, right? So if I have to do the index base, I have to use iLock. And with iLock, what I'm trying to do, rows, it is asking to get me all the rows from 1 to 10 and all the columns from 1 to 4. Okay, and I'm running it. So friends, one thing which you notice is that over here, when I say 1 to 10 in iLock, 10 is not included over here, right? It is only referring to 1 to 9. So in case of iLock, the second parameter which we are passing is not included, okay? Over here also it is 0, 1, second, and third. The fourth column over here is not included, right? So that's something which is different between lock and iLock, which you should be mindful of. Now, one of the important, if you have done, let's say list, you'd recall that there is a great way of reversing the list, right? Similar thing goes over here. If you have to reverse, let's say the rows from top down, then what you need to do is you need to specify .lock and specify this particular string. Now let's try to understand what this means. So when I specify the first thing, and there is no comma over here, right? If I do not put a comma, that means I'm only referring to the rows. The first parameter is the rows inside the parenthesis. In case of rows, what I'm trying to do, my first thing is start before the colon. The second thing over here is where I need to stop. And this thing is the step size, that how many steps I want to take, right? So start I didn't specify, end I didn't specify, but the step size I put it as -1. When I put -1, that means I want it from the back to the front. And when I did from back to the front, automatically the new data frame which is getting constructed will be reversed in order. I hope it makes sense, right? When I did, let me explain one more time over here. So let's say if I specify over here like this, what will happen? Now, this is my start, 0 to 891 or whatever number. This is my end. End also I'm not specifying, so it goes all the way till end. A step size is 2, so get me all the second ones, right? So it is skipping the 1, right? This is the step size 2, so it skipped 1, it skipped 3, it skipped 5 and things like that. When I specify -1 over here, that means I'm counting from backward, okay? Where do I need to stop? I need to stop at the very beginning. Where do I need to start? I need to start from the very last. And how do you want to go? I want to go in the reverse order. And if you run it, voila, this is reversed, okay? Now, similarly, you can reverse the column. When you are reversing the column, you have to specify a comma over here. So I'm interested in all the rows, right? By this I specified. And there is a comma. Now it's the column portion. All the columns starting from very bottom to very top and in a reverse order, -1. So what will happen, friends, over here? If you notice, if I run this, then my columns, the passenger ID was the first, 0th, it went at the very back, survived after that, right? So it has reversed my column layout, okay? Clear? Now there is something called conditional filtering techniques. So based on certain conditions, if you want to filter, now these slicings were easy. You know that you want to slice a portion of that, it is easy. But what if there is some filtering criteria also? Like we want to know that, hey, if passenger ID is this, right? How we do it in SQL also. So let's try to do that. So the way to do that is if you have to get the unique value counts, right, of any column, the way you do that is actually you can call the columns like Titanic or df or data frame dot column name dot unique. When you specify this, then what essentially you are doing, you are calling the Titanic column embarked, and then you are trying to get the unique values inside that, right? So it will give you the unique value. This is one way of counting, okay? Now, what is this conditional formatting? Now, when I say conditional, the way to call a Titanic data frame, a particular column, is through two means. One, you can specify it like this, Titanic dot embarked, right? This is also fine. Or you can specify it like Titanic parenthesis embarked. This is also fine, right? So either way of calling is fine. So you are referring to a particular column or a series in a data frame, right? So let's try to understand this, what this conditional formatting is doing. So what I'm saying is Titanic embarked wherever S is appearing. So embarked is this, wherever S is appearing, and Titanic column sex wherever female is appearing, and there is an and condition. So this condition, and Titanic survived is equal to 1. So those who survived from this column. So what I'm essentially getting is all the females who survived and has an embarked status as S. This is what I'm trying to get. And then I'm doing a head of this, that give me only the top 5 I wanted to see, right? So if I run this, all the embarked ones came, all the survived one came, and the sex was female, right? So this is how you do essentially filtering, conditional filtering. Now filter is, as I was saying, that you can call a column Titanic dot embarked also, and Titanic within parenthesis embarked also. So same thing can be written in this way also, and it will give you exactly the same result, okay? Now let's see, this value count method is also very powerful. What it does is, for any column, if you have to count the individual values, right, it will give you the count of that. So very quickly, suppose someone asks you that, hey, give me the count of total survived versus total not survived. The way to do is that Titanic.survive or Titanic's within parenthesis survive dot value counts. When you run this, it will give you the 0 count was 549. These are the people who were unfortunate not survived. The survived one is 342. So it gives you a very quick way of filtering based on certain conditions, right? Now, one of the important part of EDA is missing values, right? And Pandas was created with one of the point is that it handles missing value well. So let's see. We'll do the Titanic.info. We'll get the info over here. We have already seen that. Now, we have already seen that we know from here that cabin is 204 non-null. That means 889 minus 204 are all null values. But is there a way to quickly see how many null values are rather than doing this subtraction method? Yeah, there is. So it is data frame dot is na that, and then when I do is na, that means it is subsetting it with a boolean true and false, and then I am doing a sum out of it. When I am doing a sum out of it, it will just calculate all the true values over there. Is na, that wherever it is na not available, right? So give me all the values wherever it is not na and sum them up column wise. This is what it is, right? When I sum them up, I can quickly see that age has 177 null values, cabin has 687 null values. So without doing subtraction, you can get it in this way also. And this is a quick way of, easy way of finding that, yeah, how many null values you have in each of the columns. Let's move on. Okay, so once you have found the null values, you have to do something with it. Like, what do you want to do? Like, one of the ways, there are various ways. One of the ways is that, hey, drop the whole column where there is null values. You drop the rows where there are null values. That could be another approach. You fill the null values with something which is more meaningful. Or you drop only the column if they have too many null values. What is too many? That can be set with a threshold, right? So the first example is I'm dropping the column, okay, wherever there is a null value, okay? So I'm dropping. When I drop, if you notice, the cabin and age will not appear over here, right? So they were, because they were carrying null values, they were dropped over here, okay? Now, I didn't want it to drop just because one null value is there. I wanted to say that if there are more null values or there are many null values, I want to drop it. So that you can set it with a threshold parameter inside the drop in a method. So when I say 0.8, that means 80% of the rows or 80% of the values of that column is null, then you drop that column. So if I run this, then if you notice over here, then age has come back. So age had only 177, so it was within the threshold limit. But cabin didn't appear because cabin is 687, far too many, right, null values. So it is still disappearing from here. Okay. Now you can drop the row also, and the way to drop is that axis is equal to index. Again, same method, but axis is not column, axis is index, right? So column is this axis, columns, rows are this, right? When I did drop that, it dropped, and if it dropped, then if you see over here, everything is 183. Now tell me why it is 183. It is 183 because I'm dropping all the rows which has even single null value. And if you notice over here, cabin has 687 null values. So all the rows where cabin was null have been dropped. And that's why the null values are 183 over here, right? Okay. Fill with some values. Now another treatment could be that, okay, let me fill it with some values. So I know that the cabin was highly null values. So I am say that, okay, wherever you have found Titanic cabin, this particular column, fill NA, that don't drop NA, but do fill NA. And what you want to fill it with? Default cabin. And I want to do it in place is equal to true. That means on the same data frame, you do that. So wherever you found NaN or NA, you append default cabin. Now when I run this, you'll notice that. And then I do a titanic.info. You say that age is 714, but all the cabins are 891, right? So everything else has been appended. Now if I do a value count over here again on titanic.cabin, that on cabin data series, if I do a value count, the default cabin, the 687 were null, they have been appended with default cabin over here, right? Cool. Let's see. So sometimes there will be a need to do sorting also, and the sorting is very easy. When I say sort values, that means you are doing column wise. Okay, so titanic.sort values, you call this method on which column you want to sort. So you have to specify over here by fare, that who paid the highest fare. Ascending is equal to true. By default, ascending is equal to true. If you want the reverse order, that the maximum at the top, then you have to say ascending is equal to false. When I run this, my topmost fare at the top, right? And the bottommost fare are at the bottom, okay? So as I was saying, index are rows and values are column, right? So if suppose there is a need to sort out the index wise also, or the row wise also, then you do ascending is equal to false, sort index instead of sort values, right? And it will give you the sorted form. So sorted index is like the most index, the biggest index number will be there. Now this may not look so useful in this particular case, but if suppose you have a labeled index and those labels are like employee ID or something, in those cases it will be very useful. Now, one of the most powerful feature of Pandas is aggregation, right? Now let's see what is aggregation. Now suppose the question will be that, okay, tell me those who survived, what out of all those people who survived the Titanic accident, what was the mean price they paid for their journey, okay? The thing can easily be found like Titanic data frame. This is my column Titanic.survive is equal to 1. So wherever this condition is appearing true, I am only filtering those. And what I'm getting the fare out of it, okay, for all those. And then I'm calculating the mean of that. So when I run this, 48.39 is the fare of all the people who, mean of the people who survived. Similarly, I did it for Titanic who didn't survive, like didn't survive. That means Titanic.survive is 0 and their fare 22. Now does it tell you an interesting fact that people who paid higher fare had a better chance of survival or survived more than the people who paid lower fare? That means the people in the lower deck or people who paid a smaller cabin, their chances, they survive less than the people who paid more over here. Now let's see that the other way to do that is the group by feature. Now the group by is very similar. If you're coming from SQL background, you'll totally relate to that. But what you are trying to do essentially is you are trying to group all these rows or observations by a particular column. So I'm trying to group it by survived. Now survived has two categorical variables, 0 and 1. So I'm trying to group it by survived. And I'm trying to get the fare. Fare is my another column. And I'm trying to get the fare. And I'm running an aggregate function. Now you can provide a list or a single value also over here. When you provide a list, it is going to give you all those aggregate functions values. And then I'm doing a head. Head is actually unnecessary over here. The way it would work is that I'm grouping it by survived. Survived is only 0 and 1. I group it by this. And then on fare column, I'm running an aggregate function. So it can be sum, it can be count or mean or all of them or min. Or there are few aggregate functions which are sum, count, mean, median, and minimum value or maximum value. Those are the aggregate functions. I can run that. So when I did that, I can give a clear snapshot over here that all the survived, I'm grouping it by that. The sum of the fare is this. The count were 549 and their mean was 22, whatever the unit is. For all those survived, that means 1, their sum was this, the count was this, and the mean value was 48. So this is on the fare column, right? So it's a very powerful tool. And the way it works is that you specify the group by column name, then the column on which you want to get the aggregation done, and then pass the aggregate functions or function. Even you can pass one, like if you're just interested in sum, you can just pass sum. Or you can pass a list of aggregate functions also, okay? Now let's see, sometime what we have to do is that there is a continuous data and you have to convert into a categorical data. That also can be done. Now, what will be the situations where continuous data needs to be converted to categorical data? Let's say you are building a model where you are not interested in the exact, let's say it's a customer survey type of data. So you're not exactly interested in the customers, how much they earn or how much they spend. You want to bucket them into like gold, silver, platinum type customer, right? And your business is also okay with that as long as you are able to bucket them into gold, silver based on some criteria that, okay, if he is spending less than less than 500 rupees a month, he is silver. If he is spending less than between 500 to 2000 rupees, he is gold, and above 2000, he is a platinum customer. Something like that. In that case, you will bucket it, right? So in those were the cases where a continuous data, like a spending, needs to be converted into a categorical data, which will be silver, gold, and platinum, and then you create a new column out of it, right? So if in case of analysis or visualization, you can create a histogram also, a nice histogram also out of it, right? So you have silver and how many customers of silver, how many customers of platinum, or how many customers of gold are there, and their frequencies you can show. Okay, I hope it makes sense. So that was one of the use case. Over here, let's say if you have to convert, age is a numerical data, right, as we know. And if we did a head on age, then we see that these are numerical data, right? Now, if let's say I'm trying to create a new categorical column called updated age, and the way to do that is you do pd.cut. What the .cut method will do, you have to provide a bin also. Now, if you know about histograms, then histogram is also you have to bin. That means the first bin will be 0 to 18. 0 to 18 bin, I'm labeling it as child. 18 to 25 bin, I'm labeling it as young adult. Above 25 to 99, I'm labeling it as adult. Okay, so I'm binning my continuous variable into categorical variable. The labels are these, and the bins are these: 0 to 18, 18 to 25, 25 to 99. And the method I'm using is cut. Okay, and the column I'm passing is the age column. Let's see. And where I'm getting it out, I'm getting it out not in another data frame or series, but in the Titanic, and I'm creating a new column, updated age. If I run this and do a head out of it, if you see towards the end, it is updated age. Now the age is also over here, and the corresponding categorical variable is already created. Now, if you have to drop that age because you have already created a categorical variable out of it, the drop is easy, .drop age, right? And you drop that. Now you only have that continuous variable is converted into a categorical variable, and that column has also been dropped. Okay. Now, sometimes when we are dealing with the large data sets, then you have a need to reduce the size because there is only so much you can fit into the memory, right? So friends, if you recall towards the beginning, I was telling you that the D types and this pandas try to ascertain based on the type of data, and by default with some logic it will try to assign, right? But looking at the data, and you may notice that, okay, some are not objects, some are categories, right? So let me just, or some are not just number, they are dates. So based on that, you can modify their D types also. And this will have an impact not just on your efficiency of your model which you are going to build, but also on the size of the data which you are going to consume in the memory. Okay, so if you notice over here, I did a .info, it is 84.7 KB over here, right? And when I did a Titanic.head, this is my updated age and blah blah. Okay, now I know that my gender or sex column over here is defined an object, but we know from our experience that it is binary, it is 0 or 1, it is male or female, right? So it is a categorical attribute. So how can we convert this into category? It's simple, is as type, as type. So what I'm trying to do over here is I'm trying to get my column, I'm trying to coerce it or make it into a category data type. And then I'm feeding it back into the same column, okay? So this is how it works. If I run at Titanic.info over here, you can see that the gender or sex has been transformed into a categorical variable. And if you notice, my memory size is 78 now. What was the memory size earlier? 84. So it has also helped not only in making a variable more appropriate to its data type, but also reduce the size, and it will improve the performance or the compute which we need, right? So perhaps this was the last of the command which I wanted to discuss. There is one superhero version of Pandas. It is not actually a Pandas library, but you can use it. It is called Y data profiling. If you do not have it, you may need to do a pip install first. So the way to do pip install through Jupyter Notebook is this. I already have it I've already done the install, but it will look like this, right? It will install or you can do it through Conda or pip through the command line, whichever way you want. But you need to import this Y data profiling. And by importing, and if you pass the data frame name over there into their profile report method, it gives you magic. It gives you a lot of data. Let's see. So it will take maybe a little bit of time to do the profiling, but see the kind of content it is giving you, like for that particular data frame. So starting with how many variables, observations, how many rows and columns, how many missing, what percentage missing, everything it will give you, okay? And it will give you not just the overview, but if you see for the variables over here, now for each of the variables you can select, let me select the passenger ID, and it will give you a lot of data for that passenger ID, right? If I say, let's say survived, then it automatically gives you in a nice pictorial way the 549 didn't survive, 342 survived, and what is the memory size and all those. It also gives you the univariate and multivariate, like if you have to run the correlation sort of interactions between those two, then it also gives you like age and fear, how they were correlated. Yeah, like it can give you that sort of data also. Okay, so it gives you the heat map of the correlations, right? Obviously the central diagonal will be dark, it is 1 because the same number of things will be over there. And it will give you in a tabular format also. So it gives you a lot of insights in a very quick snapshot way where you can gain. So that's why I was calling it the superhero of version of Pandas, but you need to install it and do a pip install over there. So friends, with this being said, I think I have come to the end of this top 20. I think it was a little more than 20. I would say it is around 30 commands. But this, trust me, if you practice these commands, you will be able to solve 80% of your work. And Pandas can be confusing. When I was learning Pandas a few years back, it was sort of confusing. There are books which are written on Pandas. So this 30-minute, 30, 35, 40 minutes, a snapshot. And if you practice these commands, I'm sure that you will be able to do a lot of work and make a lot of progress. With that being said, I think I will pause the video over here. I'll see you all in the next video. Till then, bye.